So this question normally has 10 marks, 10 free marks in additional mathematics, and all you need to know is if this is your distance formula, then your velocity formula will just be the first differential coefficient of this. That is, you differentiate this with respect to t, ds dt, that will give you velocity. And then acceleration is given by, you just differentiate the velocity function, so dv dt, and this is everything you need to know. And of course, to move backwards, you just integrate. So to find velocity when you have this, let's start with acceleration. Then if you want to find acceleration from this, you just integrate this. So you can say velocity is equal to, you integrate this with respect to t. And then to find distance is usually denoted by this, because this is a displacement. You can just integrate this with respect to t, and that's all you need to know. So a particle starts from rest. So the fact that it is starting from rest means that it is starting from somewhere 0,0 at O, and moves in a straight line, so that t seconds later its velocity v meters per second is given by per second is given by v is equal to negative t squared plus 2t. Given that the particle comes instantaneously to rest at q, find the time taken to reach q. I'll talk about this word on part B. So the time taken to reach q, actually on part A, the word instantaneously at rest means that the particle is resting instantly. It's not moving. In other words, the velocity is equal to 0. Please, this word has to do with the velocity, not the time. It doesn't mean the time is 0. An object can be resting while the time is moving, but once an object is resting, velocity is always equal to 0. So we shall take advantage of this word to find the time the object takes to reach q. So the time will be, you use this equation there, v is equal to t squared plus 2t. And since time is 0 since the velocity is 0 at instantaneous rest, you can put a 0 there and solve for t. So we can use factorization. I think it's the easiest. So this one will be negative t plus 2. Then we can say either t is equal to 0 or t is equal to 2. When you take the, maybe let me just solve it. Either this is equal to 0 or this is equal to 0. Then when you take the t to the other side, you realize that t is equal to 2. So I don't think you need the units here because the formula already has them. So t is equal to 2. So you're just finding t, not t seconds, because we already know that t is in seconds. Yeah, so this one will be rejected. Why? Because this is the starting point. Of course, this thing started from rest, so we expect the starting point to be 0. So the answer for this one, for part A, will be t. T is equal to 2. And then on part B, acceleration at q. To find the acceleration, we already have the velocity function, which is this one here. So to find the acceleration, you can just differentiate this. Remember, when you have the velocity function, once you differentiate it, you get the acceleration function. So acceleration will be equal to dv dt. So that acceleration is equal to, when you differentiate this with respect to t, you have minus 2t plus 2. And then so at this point we know that t is equal to 2, so you can say a is equal to negative 2, then you put a 2 plus 2, then a will be equal to, this times this is negative 4 plus 2, so that our a is equal to negative 2. Again, you don't need the units here because this formula already has the units. And then finally we have the distance, or q. The distance from O to Q is, so we already have the velocity function again. V is equal to negative t squared plus 2t. So to get the distance from here, you simply work backwards. So from V to get to S, you just integrate your V. Once you integrate your V, then you get your S. So you integrate this, you get S. So you are moving backwards. So S is equal to the integral of V with respect to t. So this one will be negative t squared plus 2t dt. And then when you integrate this with respect to t, you have t to the power 3 over 3. You integrate that, you have 2t squared over 2. This and this will cancel out. Don't forget the constant of integration. But because we have somewhere where it says a particle starting from rest at O, so that this O here is telling you that you are starting from the origin. So as long as a particle is passing through the origin, your C will always be 0. In short, this thing is passing through this. So if you want, you can just try to substitute your zeros there. Let me just write this nicely. You can put your zeros there and you realize that your C will just be 0. So this tells us that C is 0. So our equation is S is equal to negative t cubed over 3 plus t squared, just like this. And then to find the distance, or Q, from O to Q, you can just use the time. We found the time is t is equal to 2. So you can just say the distance OQ is equal to, you put your 2 there to the power negative, to the power 3, plus you put your 2 there, squared. So this will be negative 8 over 3, plus this one will be 4. And then this times this will be 12 minus this, that's like 4 over 3. Just like this, and you are done. You have all the 10 marks.